Hi everyone, my name is Vu and this is my colleague Xintian and we are from Reddit. And today we are here to give you a talk about how we evolve our caching infrastructure from Memcache to Redis and then eventually Valkey. So let's see. So I'm a senior software engineer in Reddit, and I'm leading the whole infra storage pillar. We build a platform to support a variety of technology from Cassandra, Postgres, TiDB, Milverse, Valkey, and Zookeeper. And Xintian is our expert in the caching infrastructure part. So the mission of our team is to provide a reliable, scalable, and effective caching and database platform for all of Reddit. And fundamentally, it means we make sure we can build a reliable platform so that internal team in Reddit can build the application logic on top of it without worry too much about all of the operational burden. So, so first I'm going to talk a bit about some of the history of how our caching infrastructure evolved. So before 2022, all of our caching infrastructure are self-hosted Memcache on EC2. And this setup worked really well for us at this time, just because we just need a simple caching solution that has a simple KV API access. However, as Reddit continued to scale, this setup started to show some limitation. For example, we need more and more complex data structure to support more complex use cases. A failure of a single Memcache node become more widespread, and it makes tasks like rolling upgrade or hardware upgrade become very complicated, and it requires a lot of orchestration from both the infrastructure team and the client team. So in 2022, Elastic Cache came to the rescue by providing a managed Redis solution. So with Redis providing a rich data structure set, and with native clustering and sharding capability, this significantly simplifies the application logic at the client layer, and it makes the adoption across our company for Redis become much more wider. However, we soon encounter the next roadblock, which is some of our cluster become exceptionally large, which led to prohibitive cost, and also the fact that we lack of the internal control of the internal data and mechanics also mean that it takes us much longer to respond to incident and recover from an incident. So in response to that, in 2023, Reddit infrastructure team worked together for 2 years, and we built a platform to self-hosted Redis on EC2. And only after 2 years, we finished the implementation and migrated 90% of our Elastic Cache cluster to self-hosted Redis. And this have to significantly improve our cost efficiency as well as give us much better control of the internal data. And but that's not the end of the story. So in 2024 and 2025, as the license change happening in Redis, which forced us to explore another alternative, another technology that is backed by an active open source community. That's why in 2026, Valkey became the best technology that Reddit decided to choose. And here we are today, supporting more than 300 terabytes of data in production and more than 400 billion QPS in production. So how do we use Redis at the moment? So there are 3 main use cases that we use Redis for. The first one is a traditional caching workload where you use Redis to improve the read latency from the database. So if you read from the cache first and it is not there, then you rehydrate the data from the database. The second scenario is the second use case that you use Redis for is a persistent-like storage. So basically, you use Redis like a database. So some of the historical reason why we did this was because there are some use case in the past. They just looking for a technology that is simple to use and fast performance. And at that time, they do not require some of the database guarantees such as strong consistency or high durability. So at that time, Redis become a candidate. But as Redis continue to scale, this become a problem because the difference between the proper database technology and the caching technology start to show. And as we are migrating away from this situation, this is the state that we are in today. And last but not least is the ML feature store. So ML feature store is a use case that power a lot of our critical features such as search, personalization, or S ranking. And the latency requirement for ML feature store is extremely sensitive. So we are looking at 5 to 10 milliseconds for P99. And the data itself is massive. And the data itself is also derived data coming from our streaming and batching pipeline. So what that means is requirements such as consistency or durability is not strictly required. So Redis/Valkey is a perfect solution for this because it's fast, it can handle million requests per second, and it has provide a simple access API. So what is the challenge with, so now I'm going to share some of the challenges that we have with Redis at the moment. So memory is expensive, especially at scale, and it's trending up. And the fact that we are, and the next one is that the fact because we are doing a self-hosted Redis setup, so what that means is we cannot take advantage of the open source public operator that is built by the community. And so that means we have to build our own controller. And because we build our own controller, sometimes it has some gap in the implementation, and all of these gaps led to a significant amount of manual intervention for day-to-day operation, like scaling, rebalancing, or sharding, or failover. And some of the important feature gap in Redis, such as hash level TTL, also mean that we have to retain data for a much longer amount of time, especially for features data store, where you have a hash, and each of the key have a different TTL. Because you don't have hash level TTL, so now you need to have a very high TTL number for all of the key inside a hash. So this increased our memory utilization significantly, and with Valkey, this happened a lot. That's why that's one of the reasons why we moved to Valkey. The scalability limit of 500 nodes per cluster also a challenge for us because some of our feature store cluster has scaled beyond this number. So what that means is our team has to manually shard the data across cluster, and that is becoming a challenge. That also becoming a challenge for the infrastructure team and the ML infra team to maintain all of these clusters. So at a high level, how do we tackle all of these issues? So the first thing that we do was we work with our clients to figure out what signal that we can build to reduce the amount of data that we can put in Redis. We don't treat Redis for free anymore. So we move from storing everything to figure out which data that actually matters to store. Cuckoo filter is also a next project that we did recently last year. So even though Redis is fast, a lot of cache miss also led to non-negative cost to the networking infrastructure, and it's also affect tail latency. So Cuckoo filter is a probabilistic data structure that can help you to quickly evaluate whether it's even worthwhile to send a request to Valkey/Redis at a fraction of the cost. And I think especially for use case that you see there's a lot of cache miss, it will become a very critical solution. Key and value compression also play a big factor in improving our memory utilization, because especially at scale, we evaluate a different compression technique, and we chose Snappy, which helped us to, I think, improve 40% of our memory footprint across all of our biggest cluster. Cluster level sharding is the middleware layer that we are still actively working on at the moment. And the idea here is that by breaking down the data into multiple clusters, we can get away from the 500 node per cluster limitation for Redis or Valkey. And so which means we can virtually increase this, scale this to the infinity. And last but not least is the Redis to Valkey migration with improved performance, improved efficiency, and improved latency. And in the next section, my colleague Xiantian is going to share some more details about some of the techniques that I just mentioned, and also share about some of the results that we see so far after applying these techniques. Take it away, Xiantian.
Hello, everyone. Let's talk about some fun stuff. So first, Cuckoo filter. Over the time, we're working very closely with our customers, trying to optimize our cluster to reduce the cost and improve latency, hopefully at the same time. And one thing we learned was actual real blocker for cost reduction for Valkey is traffic. It is always high traffic that forces us to keep data in memory, and memory is expensive. One of the cluster we worked really hard on has 50 million RPIs in QPS in peak. And that, the only way to keep up with that traffic in reasonable setup is to keep them all in memory, and memory is very expensive. And what do we do there? We took one more step. We checked their traffic pattern very closely, and we will have one interesting finding that their data and traffic is very sparse. By sparse, I mean like only 2% of the requests will come back with real value, and 98% of traffic it came back with nil. They're cache misses. So how do we optimize against this specific pattern, or how can we basically serve those cache misses better? So like naturally we think about Bloom filters or Google filters. So we redesigned the data architecture. We introduced a Google filter in front of the Redis cluster. So our traffic now come to the Google filter first. If a Google filter say, okay, there's absolutely no chance that there's a value for this key, then that request will be returned like right away. If Google filter say, well, I'm not so sure, then that request will come to Redis for a real query. This Google filter is like 2% of the size of the real Redis cluster. And the result, like we were able to reduce the traffic to Redis cluster by 95%. And apart from the traffic reduction, we also see a latency improvement because the Google filter is actually a single process Valkey cluster running on a sidecar pod, which live on the same instance with the application pod. And that is much closer to the application than the Redis cluster on a remote EC2 instance. And one bad thing about Google filters is like there's no good way to update the data like in a streaming manner. So what we do is that we have like a daily job that spins up a new Google filter, scan the Redis cluster, fill the new Google filter with data, then tell the application to swap. Next is key hash and compression. The idea here is pretty simple. We want to compress the data we save on Redis, so we save both on memory storage and on traffic bandwidth. The first version we built was pretty simple. For all keys and all values, we serialize them, then compress them with protobuf and Google Snappy. And the result was like we saw over 30% overall memory reduction on the Redis cluster. And we didn't really see much latency regression because the compression, decompression is pretty fast on CPU compared to all the things happening on the network. But like we didn't stop there. There was one problem with V0 that compression doesn't work for everything. It actually increased value for simple data structures like booleans and integers. So even though it's like a net gain, but we want to do better. So we introduced dynamic data compression that only compress data for complex data structures like dictionaries and lists. And we were able to achieve another 40% memory reduction on top of the first version. And also, apart from that, a nice surprise to us is we actually saw a big drop of the tail latencies because compressed data means smaller network packets. It means smaller microbursts on the network and less network throttling from AWS. And like package job and network throttling is the biggest contributor to the tail latencies in our experiences. Next is cluster level sharding. This is to fight with the single cluster Redis scaling limit. Because like in our operations, one thing we realized was when Redis goes beyond 500 instance, like topology changes really takes a lot of time. For example, for a 500 cluster Redis cluster, if we want to add shard, we have to wait like 20, 30 minutes just to wait for all the new nodes to join and wait for the topology to converge. Then our solution was we introduced the logical Redis cluster, which is basically made up with multiple fixed-sized smaller Redis instances. Our client knows how many sub Redis cluster out there, and it's able to send the traffic to the right cluster by hash the key, mod by the and mod by the number of the clusters. The first version was simple and naive. It doesn't scale. The thing, like the second version we're building right now is like want to support live scaling by being able to incrementally add a new sub-Redis cluster to the virtual cluster and have the client to know the joining of the new Redis cluster and fulfill it with double write and switch data. Okay, I think I talked enough about Redis. Now let's talk about Valkey. That's why we're here, right? Apart from all the the amazing features and the improvements of the Valkey since Valkey 8 and Valkey 9, one of the biggest success from us was from the new feature hash level TTL. So hash level TTL in Valkey, in very short, it allows you to set individual TTL within a Redis hash item. Redis hash is actually like a dictionary as a value to a Redis key. This is important to us, especially in the machine learning feature store use cases, because their data structure was like, okay, there's a number of users and there's a number of features. Each feature has their value. And their query is like, okay, for user 1 and the feature A, what is the value of this feature for this user? So it's like a 2-level hash or dictionary. So to design the data schemas in Redis, we have to do either of the two. Either we do the top left, that we build a composite key by concatenating the user ID and feature name together. And what's good about this is now everyone has their own TTL. But the bad thing is we store the user IDs multiple times and we're wasting space there. Or we can switch from that composite key to the Redis hash, which is at the lower left the panel. And that is like, okay, we have like a Redis hash. Now we can effectively save data like for this user and for this feature, what is value. But the problem is in Redis, that entire hash share one TTL, which means we always have to use a longer TTL because we don't want to delete features earlier than they need it. But the problem is we are again wasting memory by keeping those features longer than needed. And now on Valkey with a new feature hash level TTL, we're able to combine the good thing of the two so that we can have like a Redis hash and also individual TTLs. And the result was pretty big. Like one of the recent migration, we observed like a 43% of memory reduction on that single cluster before and after migration. And you can see that metric, that was like from our production of that cluster before and after the migration. It was 44 terabyte memories used in that cluster and 25 terabyte after migration. So we saved 19 terabyte of data with one migration. So that is pretty big. And we're very happy about the result. And thank you, Valkey community, to make this happen. And cluster level, Okay, next steps with Valkey. So first thing we want to do is we want to have like a full Valkey adoption. We're working hard to trying to get our Redis cluster migrated to Valkey. We hopefully to get this done by this quarter, next quarter. There's still a long tail of cluster we need to tackle. And after that, we want to trying to see if we can squeeze more from the new features from Valkey. For example, can we reduce the preserved copy and write memory for potential full syncs, because now we have faster full sync from dual channel replications. And we're also very excited to see the upcoming 4-class BG save from Valkey 10. So Jim, please make it happen. Also, can we do auto scaling, because now we have a faster slot migrations from atomic slot migrations, or can we do multi-tenant Redis, because now we have number database support for cluster mode enabled Valkey clusters. Also, we also want to modernize our infrastructure. We're eagerly looking to can we host Valkey on Kubernetes? With that, we can consolidate the entire infrastructure across the Reddit engineering ecosystem. We can have faster provisioning, faster rotations, and we can improve the cost as well, because we create a more diverse workload for the Kubernetes team to shuffle and optimize. And we're also very excited to the upcoming launch of the open source Valkey operator, which will make the Valkey on Kubernetes easier for us. Thank you. That's our presentation.
Thank you, everyone.